welcome to The Freelancer. Today we are going to talk about a costly software mistake called arithmetic overflowing. When you are working with variables, then depending on the type that you specified, you will reserve a limited number of bytes in the memory. Because you have a limited number of bytes in the memory, you also have a maximum and minimum value that you can store in the variable. When you work with the signed type, then you have less space to store your type because one bit of your total amount is reserved for the sign. Let's take a look at the int and the unsigned int types in C#. We can see that an unsigned integer can go well into the positive 4 billion, while an integer can only go as far as positive 2 billion. On the other side, the integer can also go to negative 2 billion, so the total number of values that you can store in both types remain equal. Now what happens when we try to store a value that is too large for the type to handle? Let's examine what happens binary. When we have the maximum positive unsigned integer stored and then we try to add 1 to this value, then we will see that because the resulting value would have been presented by a 1 followed by 32 zeros, but because we only have place for 32 bits, the result will be 32 zeros. The 1 is cut off. 32 zeros for an unsigned integer represents 0. In this code sample, we can see that when we add 1 to our unsigned int max value, then our result will be 0. In the case of a signed integer, the same happens binary, so the maximum integer value is also represented by 32 ones. When we try to add 1 here, the result will also be 32 zeros. 32 zeros in an integer doesn't mean 0 though, because the first bit denotes our sign. So with an integer, we will flip from positive 2 billion to negative 2 billion. So in fact, we can say in our code that int32 max value plus 1 equals int32 min value, because the overflowing will flip all the bits. The other is also true, int32 min value minus 1 also equals int32 max value. As we can see, the default behavior in .NET is to just allow the type to overflow. We don't always want this behavior because clearly something is going wrong here. When you are working with primitive values in your code, then your code can run in two context modes. It can run in a checked context and it can run in an unchecked context. Unchecked context means that your variables are just allowed to overflow at runtime and no exception is thrown. In checked context, arithmetic overflowing will cause an exception. By default, your code will run in unchecked context. When you compile your code, you can provide a parameter to change the default context. You can also override the default compiled context by specifying the checked or unchecked context in your code. So let's take a look at the same code we saw earlier. If I put this statement in a checked context and try to run my application, you'll see that an exception is thrown. Of course, I can also change the default context from unchecked to checked, and then the first statement will immediately throw an exception even without specifying the checked keyword. On June 4th, 1996, the maiden flight of the Ariane 501 rocket ended in a disaster. Just 30 seconds after takeoff, the rocket deviated at a 90-degree angle from its intended flight path due to a software failure. What failure? Well, the Ariane 5 reused software from its predecessor, the Ariane 4. This code contained a bug that tried to convert a 64-bit floating point number into a 16-bit signed integer. Sounds familiar? The resulting conversion caused an overflow which cascaded through the system and crashed both onboard computers. The Ariane 5 cost nearly $8 billion to develop and was carrying a $500 million satellite payload when it exploded. So, a costly software mistake indeed. That was it for today. I hope you've enjoyed it. Drop me a like or a comment and I'll see you in the next video.